All right, so now we're going to keep using the dot product to find the angle between vectors, and now it'll just be in a little different context where they'll say find the angle between the lines. Well, this is a point on the line, and this is the direction of the line. So we want to make sure when we find the angle, we're going to use the directions. And then it comes down to just finding the angle between these lines where we have 12, 5, using the dot product. We're going to find the angle. Here we get negative 36 plus 20. Dot product, multiply. Over here we have 144 plus 25 square root. That's the magnitude. And we'll do another magnitude. $169 and 25. We'll do the inverse cosine, and we should get 75.7 degrees. Minus 65. All right. We need to find a vector for these, for each of these lines. So if we look at the slope can give us the vector, or a vector. So from this equation, we have 4y. Let's get it in slope-intercept form. So we're going to add 3x and subtract 12. Divide by 4. So now we have the slope. The slope is 3/4, which means we could say the direction vector is 3, because slope is rise over run. Rise is the y value, run is the x value. When we write a vector, we have the x on top and then the y on the bottom. So by finding the slope, we find the direction. And here, let's get y by itself. Divide by 5. So the slope is negative 12/5, but the direction vector is 5/12, and we just have to make one of them negative. It doesn't matter which one is negative. Let's make the 12 negative. All right, now we have two vectors, and we can find the angle between them. Go ahead and pause the video and find the angle between those vectors. (16 plus 9), 25 plus 144, and so here this is going to be a 25 square root 25 square root 169 inverse cosine, and theta is approximately 104.25 degrees. Here's a vector equation. There's a vector equation. We're going to graph them and find the angle between the lines. So it might help to write it in column vectors. So that's a starting point, and then we're going to go over 1, up 4. Over 1, up 4, and there's that line. Here we're going to go out to 10. Up 3. And this says we're going to go over 2, down 1. So we're trying to find the angle between those lines. And go ahead and pause the video, find the angle between the lines, and remember that you only use the direction vectors. Two plus negative 4. This will be 1 plus 16. This is 4 plus 1. Negative 2, radical 17, and radical 5. Inverse cosine. And we get 77.47 is approximately theta. Okay, so we have to find the slope and then use the slope to make direction vectors, then find the angle. So go ahead and try that one. We have to get y by itself. Divide by negative 2. So I subtracted 3x, and then divided by negative 2. And over here we'll divide by 5. Slope is 3 over 2, and the vector is 2, 3. The slope is negative 2 over 5, and the vector is 5, negative 2. You could also use negative 5, 2, and in this problem I'm going to use that one. The angle between the vectors, use the dot product. We get negative 10 plus 6. This is 4 plus 9. 25 plus 4. Inverse cosine, and we get that. That's an obtuse angle. If it asks for the acute angle, then you would just subtract 90 from that. That might be wrong. That looks right. Okay. Find two vectors of different magnitude and direction that are perpendicular to negative 5i plus 2j. So we could just look at vectors that are perpendicular, and if we go over 5 up 2, here we have to go over 2 up 5. 1, 2, 3, 4, 5. So this vector is 2, 5. We could also find a vector down here, perpendicular, and that's going to have to be 2, negative 5, negative 2, negative 5. And if you look at the graph and find these perpendicular vectors, you could always test them. Here we have negative 5, 2. Is negative 5, 2 perpendicular to 5, 2? So we do the dot product, and we get negative 10 plus 10 is 0. So we've checked it, and those are perpendicular. These are perpendicular. It did say different direction and a different magnitude. So we could say a different magnitude would be some number times the vector. So there's a vector that has a different magnitude as the given vector. It's also perpendicular. Multiply by some number. How about 9? So there's a vector that has a different magnitude of the given vector, and it's also perpendicular. And we'll stop there.